Hello, grade 11 students. My name is Alex. This is my Industry and Society presentation. I will try to teach you everything that I learned about my topic. I will also try to point out important information which you can take for notes. Enjoy the presentation. My topic is about silicon, its allotropes, and its application in various industries. I will start off with some background information about silicon. Silicon's atomic number is 14 with an atomic mass of approximately 28 mu. The picture at the top left corner shows you a basic implementation of silicon's atom. It is classified as a metalloid, which means it has some properties of metals and non-metals. Usually it has a cubic structure shown at the bottom left corner. Color of silicon is gray-black, as seen on the previous slide. Silicon also has very high melting and boiling points. It also has an unusual property to expand as it freezes because its density is higher than water. Usually silicon is solid but can be converted to liquid or gaseous states. There are two different forms of silicon, crystalline and amorphous. In crystalline form, the silicon atom forms 4 tetrahedral bonds with other atoms. It makes a crystal lattice pattern similar to diamond structure. In this case, the color of silicon is gray-black. In amorphous form, silicon atoms are not able to form all 4 bonds, and therefore some lone pairs of electrons are left which are called dangling bonds, as seen on the top picture. The structure becomes a random network of bonds, then does not form a crystal lattice. The color of amorphous form is brown, and it is usually found as a powder. Silicon does not react with oxygen, water, and most acids, but there are some exceptions. The picture at the bottom shows crystalline silicon reacting with a certain base. The reactions tend to be slow, but can be speeded up with temperature or gravitation. Silicon comprises 28% of all elements found in Earth's crust, so it is very abundant and there is no imminent danger of running out of it. Usually silicon is found as a mineral or allotrope. Allotrope is a scientific term for a variant form of element. For example, carbon can occur as graphite in pencil and a diamond. Allotropes have different compositions and physical-chemical properties from each other, but they all have silicon atoms present in certain amounts. In this presentation, I will only talk about 3 main allotropes of silicon: quartz, which is a shiny crystal at the top right corner; mica, which is a brown mineral that can be separated into thin sheets; and asbestos, which is made of very thin fibers. You can see asbestos at the bottom right corner, and the white spiderweb threads are actually part of asbestos. Before I move on to the allotropes, I want to talk a little about pure silicon production. It is important to understand that pure silicon production and, for example, quartz production are two different concepts. Even if both of them contain silicon, their properties differ from each other, which affect the manufacture and application in industries. There are two main methods to produce pure silicon. Method 1, to react high purity silicon with carbon, which can be found in wood, charcoal, coal, in electric arc furnace using carbon electrons, which produces 98% pure silicon and carbon oxides. However, electronic industries need even pure silicon, with purity over 99.9%. A second method is used which is called Siemens process. High purity silicon is converted to trichlorosilane gas first, and then allowed to decompose and precipitate on silicon rods. This process is able to produce silicon with purity of over 99.9%. A flowchart at the bottom depicts the process of obtaining silicon with various purities. As you can see in modern society, both methods are applied, but Siemens process is used to make pure silicon. So the first allotrope is quartz. Quartz is chemically silica, SiO2, which is on most occasions the basic formula for all allotropes. If you look at the picture at the top left corner, you can see the structure of silica, which is also a crystalline form. Even though it looks as if silicon has 4 atoms bonded to it, only 2 oxygen atoms are shared with silicon, due to its tetrahedral structure seen on the other side. 2 other oxygen atoms do not share electrons with silicon atom. Quartz is quite hard, with a hardness of 7 moles. Mole is a unit used to measure the hardness of a certain mineral. For example, diamond's hardness is 10 moles. It has a glossy luster to it. It is abundant in Earth's crust. Actually, most silicas and silicates, which are different terms for silicon allotropes, are abundant on Earth. Quartz is resistant to weathering and has unvarying chemical composition, which means it does not react with most substances. Chemical impurities in quartz, such as presence or other elements affect the color of quartz: purple amethyst, yellow citrine, or white milky quartz. Quartz has two other unusual properties and can produce electric charges if pressure or heat is applied. These two properties are called piezoelectricity for pressure-generated electricity and pyroelectricity for heat-generated electricity. These two properties are important for industries like electronics. There are two major usages of quartz. Gemstone quartz, which is chosen for its luster, color, and rarity, is used in jewelry. It is cheaper to use quartz rather than more expensive minerals such as diamonds or rubies because it is considered to be a precious, semi-precious stone. Cultured quartz, or the quartz which is specifically produced for industries, is used in electronic and frequency control devices, for example clocks or crystal oscillators. Next is mica. Mica is a mineral name given to certain minerals with similar physical and chemical compositions. All of them are silicates and contain silica. At the bottom right corner, you will see long chemical formulas for mica, but in all of them, SiO2 is present. Molecules in mica are arranged in distinct layers which are very thin. They can be separated in single sheets as seen at the top image. Again, depending on its chemical composition, micas can vary in colors. Mica's crystals are light, relatively soft, and very lustrous. In fact, mica means luster or shiny in Greek. Some of the colors can be very beautiful. Mica is abundant in Earth's crust. It is also very resistant to heat and electricity, which is why it is used in various industries. Usages of mica. Ground mica is basically a powder. Is used as an extender, filler, and a reinforcing agent in construction, paint, well-driven, plastic, and rubber industries. For example, mica-based paint has a unique color which is used in painting industry. Sheet mica is primarily as an electric and thermal insulator in electric industries. You can see some of the thin insulators at the bottom left corner. At the bottom right corner, mica insulator is used in a clamping strap. The last allotrope is asbestos. Asbestos is a mineral name given to a group of minerals that are silicates and are made of thin fibers. The fibers are quite strong and flexible. Asbestos can also vary in colors based on chemical composition. It can be white, brown, or blue. The fibers are also very heat resistant and chemically inert. They kind of resemble a hair at the closer distance, which is seen at the bottom picture. Asbestos chemically contains silica. A chrysotile structure can be seen at the top right corner. Chrysotile asbestos is the most important type, and it is used to create heat-resistant products such as yarn clothes, paper, gaskets, etc. Generally, asbestos can be easily separated into thin fibers, which are then woven into clothes. Unfortunately, asbestos is very dangerous and can cause serious respiratory problems in the long term. The tiny fibers can easily enter our alveoli. The white blood cells are unable to destroy them inside and die in the process. More dead cells start to accumulate, inhibiting the respiration. It is almost impossible to take out all of the tiny fibers from the system, which is why it is so deadly. The government strictly regulates the mining of asbestos to prevent the danger of asbestosis. So, let's conclude what we have learned so far. Silicon is very abundant in Earth's crust. It naturally occurs in allotropes. An allotrope is a different form of the same element. Silicon has three main allotropes: quartz, a hard piezoelectric and a pyroelectric mineral, is used in jewelry, electronic devices, and frequency control devices like clocks. Mica, a lustrous, soft, and heat-resistant mineral, is used in construction, well drilling, painting industries. It is also used as an electric and thermal insulator. Asbestos, a mineral made of thin, long fibers, is used to make heat-resistant products. Asbestos is very dangerous to our health and can damage the lungs. Thank you everyone for your attention, and I hope you enjoyed my presentation.